To supply cutting-edge designs to new and exciting technologies, not only do we have to step out into an industry very few have ventured, we also need to create designs that captivate an audience, just like the technology itself. We believe that this has been achieved in the design of the spaceport at Newquay, an ambitious project that has been produced to allow space tourism to take place in Europe, as well as become a place of interest and learning. Providing solutions that captivate and engage in this way is something that this small but passionate team at Aurora strive to achieve in all our work. The technology for suborbital travel is available and in the process of testing in order to provide the first commercial flights in 2018. The potential for this industry was noticed by the UK government, who proposed the idea of a UK spaceport in 2016. Since this announcement, Aurora has been working to provide a design solution that wouldn't just provide a service, but would enhance an experience for any visitor to the site. At Aurora, it was important to our team that the first project taken on was one that was exciting and provided the opportunity for artistic expression alongside high-level detailed engineering. The spaceport complex has been designed to be multifunctional. Sustainability has been a key priority for the design, which aims to integrate the spaceflight facilities with the visitors area to capture the imagination of all who visit it. Included on site is a luxury hotel with rooms reserved for the use of passengers on the space flights, as well as rooms for the airport users and visitors to the area. A cutting-edge research facility with specialist laboratories and office spaces can also be found to the west of the main building, while a hangar large enough for 2 Virgin Galactic White Knight aircrafts, a new emergency response building, and the necessary runway extensions have been added. The team at Aurora consists of a multidisciplinary group of engineers who each had a passion for supplying solutions for technology of the future. The team formed to bring together the experience and knowledge of all of these individuals. Josh Hadrill is our project manager, Rob Parrish is our renewable energy expert, Callum Doherty is our chief mechanical engineer, Ellis James is our financial manager, Kieran Grocock is our lead structural engineer, and Angus McFadzean is our risk manager. As a company, we value quality and expansive thinking. We want to provide special designs for special purposes, just like the spaceport site.
The spaceport, with its unique double-arch structure and open layout, offers an innovative design and an inclusive experience for all visitors. Alongside the creative design, this building is of the highest standards, complies with all Eurocodes and includes measures to ensure sustainability, including solar panels and rainwater harvesting systems. The primary function of the spaceport is to provide a complete service to passengers embarking on their remarkable journeys. To ensure this, a briefing room, providing a relaxing space to learn about the journey and what to expect, is provided. A well-furnished waiting room and changing facilities are also included to enable final preparations to be made in comfort. Full advantage has been taken of the opportunity to provide a unique experience for visitors revolving around space travel. A museum can be found, as well as a cinema and planetarium space that will be full of astonishing exhibits. The guidelines outlined by the British Museum have been used to help the design of the museum and to aid a thorough educational experience. Both small and large classrooms have been included, where talks will take place from industry-leading individuals. A restaurant has been installed for all users of the spaceport to provide refreshments, and this has been designed in conjunction with the CIBSE guide on energy efficiency in commercial kitchens. Situated on the most southern point of the complex, a luxury hotel has been provided, offering a peaceful space while guaranteeing the opulence of a high-end establishment. The rigorous standards of a AA-rated 4-star accommodation have been conformed to. The hotel provides 12 extravagant suites exclusively for the spaceflight passengers, which will provide their home from home. There will be 36 standard rooms for the public that provide a very comfortable space to stay. The suites provide independent lounge, kitchen and bedroom areas, equipped with the finest furniture and fittings to create an enjoyable atmosphere for the guests. The hotel will also provide a dedicated conference room floor space, benefiting guests and local businesses requiring forum space. A high-quality gym, along with massage and beauty treatment areas, are based on another floor, and on the top floor, a restaurant and bar that provide fine dining and a panoramic view can be found. Also on this floor is a cantilevered balcony, guaranteeing stunning views across the spaceport, runway, and Newquay's famous beaches. Moving north in the complex, we find a research centre and air traffic control tower. The building comprises of symmetric angular design with a 50-metre square outer area and 20-metre square inner courtyard in which the air traffic control tower rises from. Within the research building, laboratories, office spaces and staff areas will be found. The facilities have been designed to be column-free spaces and therefore very adaptable, so equipment can be moved or altered depending on what is required at a given time. The 3 large laboratory spaces are all equipped with high-impact flooring and walls. In one, a clean room facility is provided, and in another will be an aerodynamics lab, including a wind tunnel. The office spaces have been designed according to the HSE Welfare at Work standards, and a server room has been provided, along with space for a high-performance cluster. On the upper floor of the building is where the staff facilities will be provided. These are aimed to be used by staff from the entire space complex. It will comprise of a kitchen area, a rest area and a gym and fitness area with changing rooms. A green roof and balcony area for the staff to enjoy during their downtime can also be found here. The air traffic control tower has been designed both to account for increasing air traffic in the area and to act as a mission control area for space flights. It comprises of a 32-metre tall tower. The top of this houses the control cab that is 57-metre squared area at a height of 28 metres. It conforms to the FAA standard for design of an air traffic control tower. Access to the control tower is through a glass corridor from the research centre building. This takes staff from either the foyer or the staff area of the research centre through to the base of the tower. The hangar provides an area to store and maintain the spacecraft required for the flights. It will comprise of 2 large 60-metre spanning bays, each of which have a 50-metre wide door. This provides space to fit the White Knight II aircraft, which is the largest aircraft in the space fleet with a 43-metre wingspan. As specific standards to the space aircrafts are not available yet, guidance was taken by Boeing Aerospace Standards. Due to extra requirements this spaceport will bring, a new emergency services building was deemed to be necessary. Based over 2 floors and including fire and ambulance services, this will serve both the airport and the spaceport. Identified as the primary mode of travel for visitors is private transport by road. Therefore, we have designed a large car park in compliance with BREEAM and Cornwall Council guidance, which offers visitors to the spaceport the fullest opportunity to use as sustainable a mode of transport as possible. With the environment at the forefront of the design, Aurora have provided the spaceport with a dedicated electric bus service that runs every 20 minutes during peak times and also serves the existing airport on the north of the runway. To ensure the sustainable running of the bus service and the spaceport complex, Aurora have installed 96 of the bays with solar panel roofs to power the fast charge buses, private electric cars, and supply any extra energy to areas throughout the spaceport complex. All deliverables adhere to the appropriate design standards to ensure an efficient and safe design of the complex, with the structural design carried out to the relevant Eurocodes and tailored design standards. Attentive care has been taken in the design of the spaceport building, the research centre and the hotel to comply with BREEAM's guidelines for a sustainable and environmentally friendly design throughout the life cycle of the building, with all the buildings achieving an excellent BREEAM rating with scores of 80, 77 and 74 respectively.
Aurora anticipates that the completion of the project should be around May 2022. The initial design phase, including feasibility studies and the submission and acceptance of planning, will take up the first year, with 2 months after for the tendering of the project and the remaining time for the construction. Construction has been split into 4 phases. Phase 1 will include site clearance, roads and handover and is anticipated to take 5 months. Phase 2 will see the emergency services, runway extension and control tower completed and is expected to take about 6 months. Phase 3 includes the spaceport, hotel and car park and will take about 30 months. Phase 4 will see the construction of the research centre, the hangar, and will take around 9 months. Each construction stage includes a handover period with 2 founded in Phase 3 to allow the hotel to become operational earlier. Here at Aurora, we have stepped into the shoes of everyone who may feel a presence of this project to allow us to fully understand their needs and wants. Feasibility reports have been conducted on the project and Aurora's capability to succeed at this project. Risk assessments relating to the project's construction, Aurora's financial capability, logistics and interested parties have been considered and mitigating actions defined. Local job creation, land value increase, visitor increase and educational trip opportunities are just a few of the benefits of developing a spaceport for the surrounding areas. Performing a SWOT analysis has established the potential of this project whilst also considering its limitations. Being a new technology, it is expected to rapidly expand due to the large market potential, resulting in the government and companies investing into it. Newquay is a popular destination within the UK, and this project will throw a worldwide spotlight onto it, increasing visitors and boosting the local economy. Developing the infrastructure for this project is a large task, and being a young company, it could be overwhelming and require high initial capital to secure loans. The opportunities arisen from this project are enormous, with Aurora becoming a leading company in a new sector. The customers for this commercial space travel are likely to be high-profile individuals who will bring publicity to Aurora's designs. The technological setbacks have delayed the deployment of commercial space travel, which could hinder the need for a spaceport so soon. The environmental impact of space travel may also limit the number of trips allowed. Aurora estimated the total cost of the project at around £60.7 million. This value has been an accumulation of research into the costs of previous projects and finalised using advice from Spond's architect and builder's pricing book. The value has been calculated using estimates from material costs and approximates for measured work. As part of the costing process, a figure has been produced for each deliverable. It is estimated that the spaceport will cost around £12 million, the hotel to cost around £8 million, and the research centre to cost around £4 million. Due to the huge demand from the UK government to establish a British spaceport, a vast portion of the expected investment will come from 2 separate £10 million grants from the government's public spending and the UK Space Agency, helping to aid a commercial spaceflight by the year 2020. Irrespective of the current uncertainty surrounding the UK's involvement within the EU, a portion of the investment is still expected to come from the European Regional Development Fund and European Space Agency, as Cornwall is still regarded as a high priority area. The remainder of any required funding will be supplied from the Cornwall County Council. As part of a financial forecast, it is estimated that the internal rate of return has been calculated at 26% on net profits, with predicted full payback within a 4.5-year period, providing a great opportunity for all investors.
The challenge posed from this project was, can we provide a pioneering, high-quality design that will be the centre of European space travel, create a hub of learning, and provide the building blocks to boost the local economy through providing jobs and increasing tourism? We, here at Aurora, feel this has been achieved through the comprehensive design solution proposed. The space tourism industry remains an exciting, rapidly developing sector, and to be a part of it is extremely rewarding.